I'm going to review the concepts that you will see on your Chapter 256 test. So I have combined the Chapter 2 material with how it reappeared in Chapter 6.1. So I'm not going to cover that twice, so it's just going to appear once under Chapter 2. So we know the average weight of a male polar bear is 990 pounds with a standard deviation of 85 pounds and is normally distributed. Find the following. So we want to know what the z-score of a polar bear that weighs 1,200 pounds. So remember, the formula for z-score is x minus the mean over your standard deviation. So our polar bear z-score is 1,200 minus 990 all over 85. So 1,200 minus 990 is 210, divided by 85 is 2.47. Remember, we always round 2 decimal places for z-score. Next, we want to find the probability that a polar bear weighs more than 1,200 pounds. So this is where we're going to use normal CDF, and we can actually, since we've calculated z-score, we can use our z-score 2.47 with our mean of 0 and standard deviation of 1, and that gives us 0.9932. But this is the probability that it weighs less than, because remember, calculator always gives us the area underneath our curve. So if we want the probability of more than, we do 1 minus the 0.9932. So 1 minus is going to give us 0.0068. And then lastly, we have, if you want a polar bear that weighs in the top 10% of all polar bears, how much does it need to weigh? And then we want to draw the distribution. So this is an example of INV norm. And remember, it uses area below. So if you're in the top 10%, that means the area below is 90, which is 0.90. So we type in our area 0.90, we plug in our mean of 990 and standard deviation of 85, and we get 1,098.93 pounds. So if I were looking at this on my curve, okay, my mean would be in the middle, 990, and then I label the top 10%, which means 90% is below, and when we shade the area above. Next, we're going to take a look at Chapter 5, which talked about probability. We are going to look at sections 2, 3, and that extra section we did. So we know that the probability that a high schooler has a phone is 0.96. And our first question asks us, what's the probability that a high schooler does not have a phone? So remember, all probabilities add to 100. So we do 1 minus 0.96, which is 0.04. Okay. Next, we want to find the probability that 2 randomly selected high schoolers have phones. So we're just going to do 0.96 times 0.96, because we're going to assume our population is large enough here that the probability stays the same. So 0.9216. It's a pretty high probability. Okay. Next, we have a bag of candy contains 11 green, 9 orange, 9 blue, 8 red, 7 yellow, and 6 brown M&Ms. If an M&M is selected at random, find the probability that it is red. So the first thing I need to do is figure out N, how many pieces of candy we're talking about here. So I do 11 plus 9 plus 9 plus 8 plus 7 plus 6, and we get 50. Okay, so if we're talking about the probability of it being red, there are 8 red M&Ms out of our total of 50, and you either can convert this to a simplified fraction, which is 4 out of 25, or you can give me the decimal, which is 0.16. Okay. Next, we want to find the probability that is green or yellow. So there are 11 green and there are 7 yellow. So remember, anytime you're finding an or, you also have to ask yourself, are these events mutually exclusive? Because if they aren't mutually exclusive, you have to subtract the overlap. And in this case, the M&Ms are mutually exclusive. I can't pick out an M&M that is both green and yellow. So I don't have to subtract anything, which I can just add the probabilities together, and we get 18 over 50. Which again, you can write as a fraction, which is 9 over 25. Or you can give me the decimal, which is 0.36. Lastly, we want the probability of not orange. So that's the complement, probability of not orange, which is 1 minus the probability that it is orange. So 1 minus, and then there are 9 out of 50 are orange, which means 41 out of 50 aren't, which is 0.82. I guess I should put OG for orange because it kind of looks like a 0. So we're going to use the same bag of M&Ms as, should say, problem 2. But we're going to select 2 pieces of candy at random without replacement. And firstly, we want to find the probability that the 2 M&Ms are brown and then blue. So that's probability of brown and blue. So if we look, there are 6 brown M&Ms and there are 9 blue, but I'm not replacing my M&Ms, so my denominator is going to change to 49. So you can leave it as a fraction, which is 27 over 1,225. Or you can give it as a decimal, which is 0.022. Next, we want to find the probability that both M&Ms are green. So that's the probability of green and green. So the first M&M being green is 11 out of 50. Okay. The second M&M being green would be 10 out of 49, because we now have 1 less M&M that's green and 1 less M&M overall, which as a fraction would be 11 out of 245, or as a decimal, 0.045. So higher probability of selecting 2 M&Ms that are green. Okay. Then lastly, we want to find the probability of getting a green M&M and then a red. Okay. So 11 out of 50 are green, and then how many red? 8 out of 49, because again, we have 1 less M&M in the bag. So as a fraction, that is 44 over 1,225, or as a decimal, 0.036. Next, we're going to look at a table. So we're at a school. Students were asked if they drove to school and whether they were half or full day. The data is shown in our table. So we have a breakdown of a total of 400 full-day students and 200 half-day students, a total of 225 that drive, and a total of 375 that don't drive. We want to find the probability if a student is selected at random that they drive. So we go to the total that drive, so probability of driving. So total that drive is 225 over our total number of students, 600. Which 225 over 600 does simplify. It is 3/8, which as a decimal is 0.375. Okay. Next, we want to find the probability that a student drives given they are a half-day student. So remember, for given probabilities, we find the probability of both, so they drive and are half-day, and then we put it over the total of the given probability, so probability they're half-day. So drive and half-day is 110 over the total number of half-day students, which is 200, which is 11 out of 20, or 0.55. And then we want to find the probability that a student doesn't drive, so no drive, given they are full day. So we do probability of not driving and full day over the probability of full day. So no drive and full day is 285 over the full day, 400. So 285 over 400 is 57 out of 80, which is 0.7125. So next we have in your closet that there are 6 pairs of jeans, 4 pairs of shoes, 8 sweatshirts, and 11 t-shirts. How many different outfits are available if you select 1 pair of jeans, 1 pair of shoes, 1 sweatshirt, and 1 t-shirt? All right, so we're going to choose 1 pair of jeans out of our 6, so that gives us 6 options, times the number of options for our pair of shoes, which is 4, times our options for our sweatshirt, which is 8, times our option for our t-shirts, which is 11. So 6 times 4 times 8 times 11 is 2,112. Next we have that an Algebra 2 class is made up of 10 females and 6 males, and we want to find the following probabilities. So what is the probability of randomly selecting a group of 5 females and 2 males for a project? So in our numerator, we have 10 females, and we're choosing 5 of them, and we have 6 males, and we're choosing 2. And then in our denominator, there's a total of 16 students, and we're choosing 7 of them for our project. Okay, so we're going to use our calculator. We're going to do 10 choose 5 times 6 choose 2 divided by 16 choose 7. If you want to leave it as a fraction, that's 189 over 572. Or if you convert it to a decimal, it's 0.33. Okay. Next, we want our group to be made up of entirely 7 females. So we're going to do 10 choose 7 over 16 choose 7. So we're going to use our calculator. 10 choose 7 divided by 16 choose 7, which is 3 over 286. Or if you want to use the decimal, 0.0105. And then lastly, we want to know the probability of selecting a group made of 5 males. So 6 males to choose from, and we want 5 of them, over 16 choose 7. So in our calculator, our numerator is going to be 6 choose 5, and our denominator, whoops, not 16 choose 7. It's going to be 16 choose 5 because we're only doing 5 people. So 1 over 728, which as a decimal is 0.0014. Now on the other side of things, if I wanted to maintain the same group size as 7, this would have become 6 choose 5 times 10 choose 2, because if we want to have a group of 7, we would then have to have 2 females, which then would be over 16 choose 7. So this is if we wanted to maintain the same group size of 7 students. So 6 choose 5 times 10 choose 2, and then our denominator would be 16 choose 7, which is 27 over 1144, which as a decimal is 0.0236. Now remember, I will take either the fractional answer or the decimal answer here. It does not matter which you give me. So let me know if you have any questions over anything from chapters 2 or 5.